This new unit is looking at linear, quadratic, and exponential functions. So the first thing we're going to start out with are, what do the formulas look like? How can we tell in a table? How can we tell in a graph the difference between these three? So the first one we're going to start with is linear. And you guys know linear equations. And it looks like y equals mx plus b. You're very familiar with that one. So what you do here, now this one's given a table of values, so I'm going to plug in those values, and it's -2, 9, 0, 5, 1, 2, 3, 4, 5, 2, 1, 4, -3, and 6, -7. Okay, and you know my line goes all the way through the graph, arrows on both ends. So to find out what this equation is, you look at your beginning point. My beginning point is +5, so that's my b value. And my slope here is I'm going down 4 over 2, down 4 over 2, down 4 over 2, which is -2. And my beginning point is 5. So the equation is going to be y equals -2x plus 5. The domain, how far left, how far right does it go? It's all real numbers. It goes infinitely in both directions. And my range, how far down to how far up, it goes infinite in both directions. So when you're looking at this, and we want to tell from a table of values, how do I know this is going to be a linear equation? We look for the change. We look for, is there a constant change in x? So if you go from 9 to 5, you're subtracting 4, you're subtracting 4, you're subtracting 4, and you're subtracting 4. Because there is a constant change in the x, it's the same every single time, then that is a linear equation. That's how we know if we're looking at a table of values. Okay, and that should be pretty familiar to you guys already. All right, now let's look at a quadratic. So the quadratic equation, which we did at the beginning of the year, looks like this. And the squared part is what gives it that parabola shape. So if I were to plug in these values here, I get -2, -8, -1, 7, 0, -4, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now because it's quadratic, I'm going to remember that axis of symmetry that we did earlier this year. So if I had an axis of symmetry right here, then I can just go over 4 units there, and this is what my parabola looks like. Okay, now it crosses the x-axis at -5. So I don't remember if you guys remember how to do this. We're going to get more familiar with it. But when you factor this form, it is going to be x squared plus 4x minus 4. And the reason I know that's the equation is because if I factored that, I would get x minus 5, x plus 5, and x minus 1. And then when we factored it, I know it crosses the x-axis at 5, and I know it crosses it at 1. X minus 1 equals 0, so x equals 1. And so I know that that's what my equation is going to look like. And we'll talk more about that later on in the unit, but we did this factored form earlier in the year. Okay, so we know domain. Domain, how far left goes, how far right it goes. It goes infinite in both directions. So my domain is all real number. And my range, remember, is how far down to how far up. And we always go from least to greatest. So it goes all the way to -8, doesn't go below it. So y has got to be greater than or equal to -8. Now, if I'm looking for a comparison, if I have all 3 of these tables and I want to know the difference, well, what makes it linear? We already know it's that constant rate. What makes it quadratic? You can look at a table of values. So I'm still going to find the change between these. So to go from -8 to 7, you're adding 1. To go from -7 to 4, you're adding 3, we're adding 3, and we're adding 7. Okay, so when I look at that, we're adding 5 here. We're not adding 3. We're adding 5. Now, that's the first change. So to make it quadratic, we're looking for the second change. And notice when I go from 1 to 3, it's positive 2. 3 to 5 is positive 2. 5 to 7 is positive 2. It's this common second difference that I know it's going to make a quadratic equation. So if you're looking at a table of values, it's that second difference that is the constant change in x. Therefore, it's quadratic. Okay? Now, look at the one that's going to be new to us is this exponential. So your parent graph of an exponential, not your parent graph, but what the formula for an exponential graph looks like is y equals a times b to the x power. And this b right here is going to represent a common ratio, which we'll talk about. So if I look at this table of values and I graph them, 0, 1, 1, 2, 2, 4, 3, 8, 4, 16 off the charts. I see that there's an asymptote, and it's increasing at a very rapid rate. This curve right here makes it an exponential equation. Well, how do we know from a table of values? Well, hang on. First, let's do domain. How far left does it go? It goes forever. How far right does it go? It goes forever. So my domain is all real numbers. My range, how far down does it go? It's never going to exactly touch 0. So my range is going to be y is greater than 0 because this x-axis represents an asymptote, which we'll talk about later in this unit. Okay, so let's go back to the table of values. When you see this table of values, how do you know that it's an exponential function? Because it's not increasing at a steady rate. This goes up 1, up 2, up 4, up 4, up 4, up 8. So what it is doing that's the same is that you can multiply by 2 on all of these. Notice these was just we added or subtracted, but on our exponential, it's that multiplication which makes it that common ratio. So 2 is my common ratio. So this is going to be y equals 2 to the x power because 2 represents that common ratio. So this is just kind of an introduction to look at what it looks like in graphing form, in table form, and up there with my equations. So if you're struggling with that, come see me.